Hello, this is Irv Shapiro with Make with Tech. Over the last few years, I've looked at a lot of Creality products, beginning with the Ender 5, then the Ender 3, a 3D printer that really revolutionized the landscape of consumer-grade, hobbyist-style 3D printers. More recently, a number of the Ender 3 S1 printers, which are once again changing the landscape of 3D printers by putting prosumer-grade products into the hands of hobbyists at an attractive price. I've never looked at a Creality laser. I've looked at lasers from Xtool and Ortur, both very good companies that make 10-watt and higher-powered lasers that work quite well. Now, Creality has been in the laser business for a little while. They've offered upgrades to 3D printers that allow them to be used for laser engraving. Until recently, there really weren't any options in those upgrades that could be used for cutting materials other than perhaps paper. And they also offer the Falcon laser, which is a 10-watt unit that competes with the Xtool and the Ortur laser. Today I'm going to look at something very different that hasn't been announced yet. It will be announced in the next few days, and this video will go live after it's announced. And this is the new Falcon 2. What's different about the Falcon 2 is that it's a 22-watt diode-based laser. It uses 4 6-watt lasers with the beams being routed together and focused in such a way that you end up with 22 watts of power. It also has some other very unique characteristics. And so if you're interested in lasers, whether for cutting things or engraving things, then this is a video you're going to want to watch. So stay tuned and let's learn something together. If you're new to watching Make with Tech content, then I'd like to let you know we're more than just the YouTube channel. We also have a website blog with getting started guides. We have a community at forum.makewithtech.com where thousands of people share ideas about 3D printing and other maker technologies. And we have a place you can go to create custom models for 3D printing and for laser cutting called models.makewithtech.com. These are not stock models. These are models you can customize. So I encourage you to visit all of the Make with Tech properties. Now, before we talk about the Falcon 2, let's level the playing field a bit if this is your first video about lasers. If not, skip over this section. There are really 3 classes of lasers available to consumers. They're diode-based lasers. A diode laser is the type of laser you see in one of those pointers, but at a bit higher power. Diode lasers are good because they're inexpensive, and with a revolution in the last few years where multiple diode lasers could be combined together to generate a higher powered, very focused spot, they're now able to not only engrave, but also to cut materials. You'll see I've easily been able to cut 1/4-inch plywood, which is about 6 millimeter plywood with this laser without any difficulty at all. The limitation of diode lasers is they operate in the blue light spectrum. The color of the laser impacts the materials that it can cut. And diode lasers pass right through glass. So you can't cut glass with a diode laser. And you have to put a coating on the glass of some type if you want to engrave it. And then what you're effectively doing is heating up the coating, and that causes the engraving of the glass. And generally they cannot cut metal. Same reason. There have been CO2 lasers available for a long time. CO2 lasers are much higher powered. They generally start at 40 watts. This one is 22, and this is high powered for a diode laser. And they work in the infrared spectrum, much longer wavelength. They have different characteristics. Unfortunately, because of their construction, they're also generally not suitable to cut metal. But for other items, they can be very powerful and cut through fairly thick wood and other materials, plastics, acrylics, easily. And then there's a class of lasers that are more industrial, that are just becoming available in the consumer space, still at thousands of dollars, called fiber lasers. And these use generally infrared frequency lasers that are amplified using fiber optic technology. And they are suitable for cutting metal. So what we're looking at today is a diode class laser using multiple diodes to amplify the laser beam. So let's look at the Falcon 2 and see what its characteristics look like. Well, first, what you see here on the desk is basically what came in the box. It's 99% assembled. The only assembly consists of screwing the feet in and taking the laser head, this module here, sliding it into this gantry and plugging it in. That's the only assembly. So it's not an exaggeration in this case to say you'll be up and running in 5 minutes. I've mentioned it's 22 watts, made up of 4 6-watt diodes. The work area is basically 400 millimeters square. It's actually 410 by 400. Now the laser is a blue light laser. That means that you cannot cut glass, and while Creality is advertising that it can be used to mark metals or even cut some metals, that's something I have not tested yet. The laser is able to move very quickly at 25,000 millimeters per minute, which is quite fast. But one of the features that's most unique about this laser, you notice this tubing along here? And the tubing actually comes all the way down here. This tubing plugs into a pump. This is called an air assist pump. That means that when the laser is burning, it can blow air on the area around where it's burning. That keeps the area around where it's burning from also discoloring. And I will tell you, of all the lasers I've used, this one produces the cleanest cuts. Generally, if I run my finger along the edge of a cut piece of wood, I'd get a black mark. This has done a very, very good job with this integrated air assist. It is G-code based. That means you can probably use a variety of software with it. I'm running a Mac, and the best software for me to use on a Mac that's also available on a PC is called Lightburn. Now, Lightburn is really a prosumer grade product. It's a product you could use professionally with a CO2 laser as an example. But the version that works with G-code based lasers, such as this one, sells for $60. So you're going to spend anywhere from about $1,000 at the announcement sale price for this laser to about $1,200 at full retail. I'd say spend the $60 on Lightburn. It's an excellent product. That's what I'm going to be demonstrating today. Now, one of the reasons that's a reasonable thing to do is because in addition to the air assist being included with this laser, they also include this honeycomb platform and this metal sheet that goes under it. So you put these on your desk, you put the product you're going to be cutting on top of it, and that protects your desk from the laser. These normally you have to buy separately. Now, the only disadvantage of this is relatively small in comparison to the size of the laser, but it absolutely will get you started without spending anything else other than my recommendation of spending $60 on Lightburn. There are extensive safety features on this laser. There are 3 LED lights that come on the laser every time you turn it on that verify the airflow is working, that there's no fire, there's a fire detector in this head, and that the lens is clean. In addition, if you tilt this, it will automatically shut off. There is an emergency stop button on the top that's only available in the higher end models from some of the other manufacturers. There's a key switch. That's a wonderful safety feature. If you have children in the house, you don't want them turning this on by accident. And the next thing is very interesting. There's no Wi-Fi in this laser. Some of their competitors have Wi-Fi. I didn't find the Wi-Fi really very useful. It wasn't very reliable. It was hard to configure. What they do have in here is the ability to print completely offline. So you can save your G code from Lightburn to an SD card, and you can print offline, including the initial positioning of the start position for your laser. This is powered by a power brick. This is a big power brick. It is, let's see here, it is UL listed, and I'm not familiar with the brand, but it worked very reliably. I had no trouble with it. So I set up this laser. Assembly was about 5 minutes. I put this underneath. I installed the software in Lightburn. I was up and running completely, including software installation, in 10 minutes. It'll probably take you a little bit longer if you've never used Lightburn. Okay, now I'm going to bring a computer up here so that I can take and show you how you actually install and set up this laser. I have my laptop here. I've gone to the Lightburn website and downloaded the current copy of the program. You can download a trial, or you can pay the $60 for the software. If you're on a Windows machine, you can get a trial off the SD card that comes with the Falcon 2. However, I'm on a Mac, so I went to the website. In general, I like to go to the website. I think you get a more current version. The laser comes with a USB-C to USB-A connector. It also comes with a little adapter to go USB-A to USB-C. I needed to use that because I'm on a MacBook Pro and there are no USB-A connectors. So I have that plugged in here. Now, because I've loaded Lightburn before and installed other lasers, it's not going to prompt me to install a laser before it will continue. But I can simulate that. So let's look at the screen. I'm going to click on Devices here, and I'm going to select to import a laser that Lightburn doesn't know about. Brand new laser. There's no way it could know about it. I'm going to click on Import, and I've taken and loaded that onto my hard drive. And this is just a copy of the SD card. So I'm going to go there, and I'm going to go to the software directory, select the Lightburn trial directory, select English, and select the configuration file. So now you'll see there are 2 Falcons here. I'm going to actually delete the second one since we won't need it. So I now have Lightburn configured to use with this laser. But now we need to make sure it's on the right port. So I'm going to turn on the laser. If this is the first time you're attempting to turn it on, this emergency shutdown button may be in the locked down position. You have to turn it a half turn to get it to pop up. You also have to make sure the key switch is on. If the key switch is off, the laser will not come up. Now, once the laser starts, I need to make sure that this USB port is properly configured in Lightburn. So next to where it says Devices, see here it says CU Bluetooth. This isn't on Bluetooth. So I have to click on that. I have to click on the port that it's on. Now, how do I know what port it's on? Well, there's a little trick you can play. Go into that box when there's nothing connected, when the laser is off. Then turn the laser on, go into that box again. You'll see a new line. That's your laser. So I'm going to click USB modem, which is what it's called on a Mac. Now, if it's properly configured now, if I click home, you'll see the print head do that little dance. In fact, I could move the print head all the way here to the middle, click home, and it would go to the origin. That's going to be very important. But first, I want to do two other simple things. I want to go to Lightburn Preferences. I want to make sure this is selected millimeters per minute. Click OK. Then I want to go to Edit Device Settings. And I want to make sure that Enable Laser Fire button and Laser On when framing are set on. Now what that will do is it'll turn the laser on at a very low intensity. It won't even mark a piece of paper. Just bright enough so I can see where it's at when I'm lining up the laser. And we'll show you how that works in just a moment. Now I'm going to click OK. So now we're ready to get started. But before we do that, we have to pick a material. So I'm not going to use wood. And the reason I'm not going to use wood right now is it creates a lot of smoke. I'm in the basement of my home. If I create a lot of smoke down here, it's going to be very ugly. It's not going to be good for me. So normally when I print, I'll show you a picture. I have this, when I cut with it, I have this in a tent. The tent's connected to a vent that exhausts the smoke right outside. But since this is right in the open here, I'm going to use something that will not create a lot of smoke. So Creality gave you a bunch of pieces of wood, one piece of metal, lots of felt for some reason. So I'm going to take a piece of felt. But there's a problem with this felt. Look at how this is shaped. If I go and try to cut this, it's going to be closer here and further here. So I need to sort of find a way to flatten it out. Now I could actually, if I wanted to be careful, I could actually take and use some masking tape and tape it down. Now, my laser's homed. That means the laser is right here right now. If I go over to where it says Start From, see it says Absolute? Well, that's what I want. That will allow me to put this piece of felt right in the middle where I want, then put my image in the middle here and align it that way. So the exact center of this grid will be the exact center here. I literally could take a ruler and put it on the two corners and find the center and mark it with a dot, and I'd know where the center is. Alternatively, you can use this laser in a different mode where you manually position it and say start from the position it's started in, or you can do something called aligning the origin, more complex than for today. So we're just going to leave it in absolute mode. We're going to make sure it's homed. And now we're going to take and put this in the middle. Now, the next thing we need to do is we need to focus the laser. You may have wondered what this little piece of metal is, and it says engraved cut thickness of basswood 1 to 3, thickness 4 to 6, thickness greater than 6. Well, the reason is this is actually a fixed focus laser. All the lasers in this class, the current ones, are designed that way. And that means that you need to just make sure the lens is a certain distance from the center of the material you're trying to cut, or from the top of the material trying to engrave. So if your material is thicker, you need to put it down lower so the focal point will be at the right place. This is a very thin material, so I'm going to pick the thickest level here. So what I do is I manually move this over. I take and I loosen the two screws on the side here. I lift it up a little bit. I slide this underneath so that the laser is resting on the block that's on top of my material. Then I take and I screw this down. Now the laser is focused for that material. So let's actually just cut out a shape just to see how this works. So let's say I take a polygon here. I draw this in the middle because remember we're in the middle. And then the next thing I have to do is anytime I'm using a laser, I have to determine the power, the speed, and the number of passes. That will determine how it cuts. Now, how do I know that? Well, there's a cheat sheet that comes with this laser, and over time, you'll experiment and find what works best for you. So this says that for felt, I want the power to be at 55% and the speed at 4,000. So I'm going to click on the arrow and select the item on my screen that I want. I'm then going to set the speed to 4,000. And I'm going to set the power to 50%. Let me double check that I got that right. 55%. Now, how does Creality know that? They experimented. So every time you're going to use a new material, it's like in 3D printing, you use a brand new filament, you might have to mess with your slicer. Well, you use a new material with a laser, in particular for cutting, but also for engraving, you're going to have to mess with these settings. So now I want to make sure that when I go to cut this, my laser is in the right position. So I'm going to home it first. That's going to bring it back to this corner. Then I'm going to click on frame. And it's going to show me where it's going to cut. Okay, so that looks like it's pretty much in the middle of my piece of felt. So once I've done that, and the steps were to reiterate, you set the focus with the block, you set the power and the speed, you check the framing, then you hit start. And we're going to make a little bit of smoke, but probably not enough to get me in too much trouble. And we're all done. Now, let me take and see if I can pick this up here. Here we go. We made our first cut. Okay, now, let me just erase this item by selecting it. Whoops. Selecting it and hitting delete. And now this time, I'm going to do a file import. What kind of files can I import? Well, a variety of different formats, but the format used most often is SVG. So I'm going to say import, and I'm going to import something called a merit badge. This is just a print that I got off of Thingiverse. Now you'll see it imported as having two different areas. In essence, there's this outer line here, and there's the inner shape. It's hard to see, but the surrounding box moves when I go between them. Now to make it a little easier for you to see on the screen, I'm just going to change the layer it's on. There can be up to 28 layers in Lightburn in this version. So I'm going to click on a different layer color. Let me click on red, layer 20. Makes no difference. The program's going to execute in the order top down. So now you can see there's a red line here. So that's where I'm going to want to cut. And this line is where I want to engrave. Now I can engrave with lines, or I can tell Lightburn to fill in the lines and engrave a solid. That's an alternative. Now, this is felt. So once again, I would look up on my chart. So engraving of red felt is 13% power at 6,000. So I would fill this into 6,000, 13%. I can also fill that in down here. I don't have to double click on it. And cutting was, because I'm going to want to cut the outside, if I leave this in felt, once again was 55%. So I would set the power here to 55%, and the speed for cutting felt was 4,000. Okay, so that's how I'd set up an item that has both an engraved area, the black area, and a cut area, the red area. So what's the difference between engraving and cutting? It's just power, speed, and potentially number of passes. Let me show you one more thing to get you started. This time, I'm going to say File Import, and I'm going to import a picture of Albert Einstein. Now this is a little too big, so I'm going to grab a corner and make it smaller, move that back into the middle. I'm hitting Command plus and Command minus on my Mac. I believe it's Control plus, Control minus on your PC. And we see this image. The image looks great on the screen. it probably won't necessarily engrave well. Now you see it's listed as an image. We still set power and speed based on the material by looking at the engraving settings. But let me show you something else you can do. There we go. You have to select it, then right-click on it and say Adjust Image. And you can change how it converts this image, this picture, into something made up of lines or dots, depending on the type of conversion, that you can then engrave on a laser engraver. Well, that one doesn't look very good. This one's not bad. You can see the dots are a little bigger. When the dots are bigger like that, it's generally easier for the laser. Very often people use the Jarvis converter. And you can see here there's not a lot of contrast in this area. So I might increase the contrast a little bit. And those are all things you adjust in order to maximize the quality of your image. How do you know what it should be set to? Pretty much trial and error. Now there is an option here, if I go to Adjust Image, to select a preset set, and there is a preset called Basic, which is potentially a good starting point for using with the engraver. So we talked about cutting, we talked about engraving, we talked about using them together, and we talked about images. Now, let me shut down my laptop here, make a little space, and let's go through some examples, and we'll see what the quality is, what this printer is capable of producing. To begin with, I took and I did some simple cutouts just to see how well it worked. This is 3mm basswood that I bought on Amazon. And while my other lasers say it'll cut it in one pass, they struggled to cut it in one pass. I generally used 2 passes. So I want to see how well this would work. So I took and I drew a rectangle. I looked at the guide for basswood, and it produced this cut. Now let me tell you what's unique about this cut. First of all, there is no scarring. There's no shadow on the back here. That means that it wasn't over lasering. It wasn't getting too hot. Number 2, generally when I cut this material, if I run my finger along the side, I get like charcoal marks on my fingers. I didn't. This cuts extremely well, this laser. So the next thing I tried is a little more complex model. I showed you an example of this when we were setting up Lightburn, and this is out of the same material. I set the middle to engrave. I actually increased the power a little bit over what they recommended because I wanted it to be a little deeper, a little darker. And I set it to cut the outside. And this is a really beautiful example. For creating signs, this would be a wonderful, wonderful device. Next, I decided to try some engravings. So I showed you the picture of Einstein, and this is the first result. It's not very good, but I noticed there are a couple things. First of all, this piece of wood is not even close to being flat. So that means the distance to the laser is different here than here. That's going to be a problem. If you want great engravings, you need perfectly flat material. Number 2, it's very rough. So I tried doing another one. I sanded the material first. I experimented with some parameters, and this is a better result. Still not perfect, but better. So it just shows you that for engraving, you're going to have to experiment. But the things I've showed you so far, I could do on a 10-watt laser. So what can't I do on a 10-watt laser? Well, this is 1/4-inch basswood. I've never been able to successfully cut 1/4-inch reliably. This cut in a single pass on this laser. I think this took 18 seconds to cut this out. Once again, it's extremely clean. But a lot of the plywood you get is not basswood. If you go to your local lumberyard, you're not going to get basswood, but you can get birch. So this is birch plywood, also cut 1/4-inch without any problem at all. That's something I couldn't do on a lower powered laser. Next, I tried an experiment that had failed on my other lasers. I had this sheet of black acrylic. I don't really know what kind of acrylic this is, but in this particular case, let's see here, it's about 3 millimeters. And I tried to cut this on a different laser. It failed. It also failed on this laser. However, I was sure this laser advertises it can cut acrylic. So I found a sheet of yellow acrylic, different manufacturer. This is actually thicker. This is about a 1/4 inch. So this is between 5 and 6 millimeters thick. And I had to try this twice because the first pass it clearly cut properly, but didn't go all the way through. So I used 2 passes, and if you look on the side, you actually can see the layers. So this would take some tuning, but this did cut out successfully. Then I got greedy. I decided to take something very complicated, a flower, and try to cut it. But I forgot one of the things that impacts lasers a lot. And that is, I found that the ratio between the depth that you're cutting and the details you want are inversely proportional. What that means is, if you have a thicker piece of material, don't expect really fine cuts. So this flower did not come out very successfully. And in fact, it looks like the plastic was melting a little bit, which means I didn't have the settings proper. But I wanted to make sure that I could cut that fine detail on this laser. So I took a piece of construction paper, the exact same model. It came out absolutely perfect. So, and it's very interesting, because of the air assist, I have no dark marks on the edge of this paper. So this is a laser you could use successfully for paper cuts. Next, I wanted to do something a little more practical, just to demonstrate to everyone the types of things you can do. So on Thingiverse, I found this napkin holder, and this was cut out of, I believe this is 3 millimeter. No, this is 4 millimeter basswood plywood. It was absolutely perfect. Did generate a lot of smoke. Good thing I have it in a tent. So what have I learned about this particular device? First, and you can see this on the screen here, because of the integration of the air assist, the higher powered laser, and the print surface, the engraving surface, the honeycomb engraving surface, this is really a best buy in my opinion. This is a very good combination of features. The quality is outstanding. Once again, higher power and air assist. It works seamlessly with Lightburn, and the assembly is trivial. But let me tell you one other thing about the assembly. These feet on the bottom can be put in different positions. So I couldn't fit the other lasers on the table you're seeing this on here. I had to put a sheet of wood on top. But because I can position the feet in closer, it fits on this table easily. In addition, the feet are much higher than the other lasers I have, where I had to put spacer blocks underneath to use certain types of materials. And there it comes with extension feet. So overall, good value. The safety features are well done, and they seem to work well. The emergency shutoff I've tried, it works without a problem. What are the negatives? They're not a lot. One is that while Creality is promising a rotary mechanism so that you can engrave on round objects, not available yet. And I'm not even sure how it's going to connect to the printer, because there is no plug. On the other devices that I've used, there was a separate place to plug in a rotary accessory. What that connector does is give you an alternative to the Y-axis. So you have the X-axis, well, let's say this way, moving side by side. You have the Y-axis moving back and forward. When you put a rotor in there, the Y-axis is turning the rotor instead of moving back and forward. The X-axis works the same. So I assume you're going to have to unplug. There's a plug sort of buried in here to add that device. That's not necessarily as convenient. The instructions, that are on the SD card are very, very good. The videos are very good, but the instructions for upgrading the firmware weren't very clear. I've shared that with Creality. They say they're going to improve that. This focus block is a very interesting way to do it because it acknowledges the fact you want to focus at a different height depending on the depth of the material. The other lasers I've used have little legs that come around. They basically use the same height for every material. But I'm concerned that I'm going to lose this. So if you can buy an extra one, I think I'm going to try to get an extra one. It doesn't appear that there's an easy place to hook this on. Don't know. But I'd love it if there was a little place to store this. So overall, I highly recommend this device, and I've enjoyed doing this review. Well, folks, if you learned something today, if you enjoyed this, give me a thumbs up. If you want to discuss this video, go to forum.makewithtech.com. Thanks so much for watching, and let's continue to learn things together.